Hello friends, welcome to Veteach. Today we are going to discuss about the model paper for the subject object-oriented programming through C++. Second BTech first semester regular examination R19, and this is the model paper from Veteach. According to this R19, we have 5 units and 10 questions from 5 units, 2 questions for each unit. And the first question, and we are going to expect from unit 1. And as we know that from unit 1, the introduction part of the object-oriented programming through C++, and these are the expected questions we are getting from unit 1. The most important question, the first one is differentiate between C and C++. Sometimes this may ask in the way of question like procedural approach and the difference between procedural approach and object-oriented approach. And the differences, what the main features are available in language C and the features that are added to C++. And these are the differentiations need to be covered more in differentiating these two type of approaches, C language and C++ language. Okay, here it is the answer for first question, that is the differentiation between C and C++. And these are the some listed differentiations, differences between C and C++. And as we know that C is a procedural language and C is a object oriented language, and data is not protected in C, but here data is purely secured in C++. Like that, and some important feature is not there in C, that is inline, and that is supported by C++ language. And operator overloading is the one, is not the feature available in C, and whereas this operator overloading is mostly important feature added in C++. And C, it's a top-down approach, and C++ is a bottom-up approach, and namespace is not available in C, and whereas namespace feature is completely given some feature to avoid this name collision in C++. And multiple declaration of global variables are allowed in C, but here it is not allowed in C++. Coming to the input and output operations in C, and we have two functions, scan and printf, and whereas in C++ we have cin and cout. These are the objects for the input stream and output stream classes, and these objects are used for input, giving the input to the program, and as well as the collecting the output after processing the data given to our C++ programs. And whereas coming to this, the mapping between data and functions and default and complicated in C, but here it is completely taken care by these objects, and data along with the code that can be organized in a C, and it will take care of these operations clearly and mapping between these two in C++. And whereas in C, the main function can call main function through other functions, but it is not allowed in C++. And C requires all variables to be defined at the starting of the scope, but C++ allows you can anywhere of your program you can allow to declare the variable, and but the condition at the time of its first use you should define it in before usage. And no inheritance provided in C, but here inheritance is possible in C++. And like some memory allocation and deallocation point of view, in C we have some functions like malloc and kellogg, but whereas in C, C++ and new and delete operators are used for allocating memory, and delete keyword is used to deallocate the memory. And some built-in and primitive data types are support in C, but whereas it supports both built-in and user-defined data types in C++. Exception handling is not there in C, but this is the one of the most important feature that is added to C++ for controlling runtime errors, nothing but an exceptions. And no virtual function concepts there in C, but in C++ this virtual functions achieves the runtime polymorphism, that also very interesting feature added in C++. And polymorphism is not possible in C, but this concept of polymorphism can be used in C++ language. And these are the some list of differentiations between C and C++. First question B. What are the advantages of object-oriented programming and explain each one? So here it is the advantages of object-oriented programming. The first one, programs can be comfortably upgraded because by using this object-oriented programming approaches, the updation of the programs or softwares can easily updated by using C++ language like object-oriented languages. And using inheritance, we can eliminate redundant program and we can achieve some reusability of code that are already designed in the previous classes. And here it is the technology of data hiding facility the programmer to design and develop safe programs, because here it is the concept and we seen that one that data is not protected in C, but whereas in C++ the data is completely protected. Why? Because here it is the data hiding facility is provided in C++ as a property called abstraction. And the object oriented programming changes the way of thinking of the programmers, because the way of thinking, why? Because the C is a top down approach and whereas C++ is a bottom up approach, and here it is all something modularity is more extended, and the user defined data types like classes and objects concepts are incorporated into the designing of the program. The automatically the changing of this one, the thinking, the way of thinking of programmers changed because in designing the programs and solving the very complex problem. So that are the advantages of object oriented programming, that one. Next, coming to the second question from unit 1, the another important part of this one is from unit 1 is the important features of object oriented programming. These features are also called as a key concepts, and we are going to see these key concepts one by one here. Okay, here it is the key concepts of object oriented programming are called as a features of object oriented programming, and these are the different types of important key concepts we should be aware before going to work with the object oriented programming designs. The first one is, what is an object? Object is nothing but a runtime entity, nothing but instance of a class. Then class is a data type, and where it holds the data along with the code data, and code nothing but operations on that. The class is a collection of members. Okay, next one, method. Method is nothing but a function which contains the operations that are going to apply on the data. And these data plus code both can be organized in a class, and method is nothing but a function which is nothing but code and which are applying on data for processing. And here it is, object is holds these data members for processing. And data abstraction, as I told you, this one provides the protection to the data we are organizing for our program, and it is completely one the facility called data hiding facility. And encapsulation, this encapsulation is nothing but in a class we are binding this data along with code into a construct called class data type. So here it is the concept, this principle is working for very important feature that are added to C++ to maintain this data along with code, nothing but then usually we know that class is nothing but a collection of members, and these members may be data members or maybe functions, nothing but member functions. And these functions contains the operations that are operations are performing on the class data. So this concept of what I am doing, it is the class data along with code is nothing but a encapsulation. And whereas coming to this inheritance, inheritance means adopting the properties from one class object to another class, or maybe made available of the properties or the code designed in the class upper class, and we can possible to extend to the below classes. So here in this inheritance we already know that there are possibility of reusability for this inheritance. Reusability is the concept we can achieve by this using inheritance. In this inheritance, where there are multiple inheritances, there are different types, there single inheritance, multiple inheritance, multi-level inheritance, like that. And the polymorphism is nothing but poly means many and morphism means forms. So it can mean of many forms, that it means when a class or a function or maybe one thing can be act as a multiple objects, like that. Dynamic binding, nothing but at runtime we can add something linking to the working function to where this applicable process is going to apply on the data or object. Here it is message passing. So while communicating with each other, that were during the process of in using the C++, and as we are constructing programs based on class and objects, these objects need to be communicate with each other one to one, and for making proper processing on the data. So this message passing mechanism should be worked there. And this one is the reusability. So reusability can achieved by applying inheritance on the between the classes, nothing but that inheritance gives and provides the something relation among the classes that are useful for this reusability. And the delegation is another type of relation, not like an inheritance, it having some more other relation for getting another important feature of this object oriented. And generosity is the most important feature for working with the templates programming, nothing but generic programming, without defining any predefined of these data types. We can work for the processing the data, and at the runtime you need to specify what data are going to be used in your program. So all these features are going to be considered as a important features or a key features. Let's have a look of one by one. But let's check, like this one is an object is a runtime error or a real-time entity, and these are all the different objects like this, and this is the representation of object in the memory. Next one, the class. So class is nothing but a grouping of objects, and class binds the data and its related functions together. Class is an abstract data type, and here it is the class declaration should be live. So consider this is a class home containing the members like this, and the class car contains the properties and actions like this. The class gives complete behaviors of the nothing properties of an object. So here it is also nothing but a blueprint of an object. And method is nothing but a operation required for an object or an entity like that one. So here it is, these are all the called member functions, all these are called data members. And very key important, data abstraction. As I told you that when it take an example, pen just gives an abstraction of something like, and we will concentration out how to use this pen, and what actually the background details completely hidden from the user, because this abstraction provides the procedure of representing essential features without including the background details. So that is like that bike and car. When we are using the bike, and why how to use this bike to travel just like going on ride like that, but without knowing that how this gas and braking system are working in this bike device is not completely hidden from the user. And encapsulation, as I told you, this is a mechanism that binds together code and data. Inheritance, as it is extending the properties of one class to another class, and class holds some data properties like members and functions, and that can be used by any class extended this property, base class and parent class like that. And we know that base class is a parent class and derived class is nothing but a child class. Here it is, the properties can be extended from this base class to derived class. Here it is an example, yellow, red and blue. So yellow and red combination, it gives automatically orange. A new type of property can be created by using like this. This is called inheritance. And polymorphism, here it is, polymorphism means one interface and multiple methods. Here it is, it allows the same function to act in different ways in different classes, just like this. Line is a type of one interface. By using this, like we can construct one dotted line or a single line or a dashed line like this one is considered as a polymorphism in C++, and this is also an important property of C++, object oriented programming. And here it is, dynamic binding and message passing, and these two also one of the key concepts. So dynamic binding is nothing but a late binding where it works at a particular runtime, nothing but execution time, until the code present in the specified program is unknown till it is executed. So this is considered as a polymorphism. At runtime only we can give some particular operation or data type, we are going to work on this processing. And message passing, as I told you, the message for an object is demand for implementation of the process. What operation is going to be performed on the data held by the object, and this the message passing gives the information or message to the object to perform that particular process on the data, just like this one. Here it is reusability. So Object oriented reusability is nothing but by extending them to other classes using inheritance. As I told you this, by using this inheritance we can get the properties, make use of next time, that it reduces the time and code size also like that. Delegation is one type of relation, but not like that one. Here it is, inheritance is a kind of relation, whereas delegation is a has a relation, and both are having some different meaning. And generosity is a declaration of variables without specifying exact data type. The compiler identifies the data type at runtime. This is very important. By using templates we can achieve this generosity of the program in the designing of the programs. These are the some key concepts of object oriented programming. Next, we could quickly move on to the next question B. What are the disadvantages of conventional programming? So conventional programming is nothing but an existing programming languages before this C++ invention. So like this one, conventional programming, like just we know very well about the C language, and whereas some disadvantages are there in C, and to reduce this one or overcome these disadvantages, and C++ is specifically added some features to reduce this type of limitations in C. Here it is coming to the disadvantages of conventional programming, and we know that generally program code is very large. It is inconvenient to manage it, whereas in CE designing of programs may lead to take more size to design programs, whereas C++ reduces this by applying the bottom-up approach. And here it is, to overcome this problem and procedures and subroutines, nothing but a modularity concept is adopted for making these larger programs into divided into smaller programs. And here it is the concept like flow of functions in non-object oriented programming languages, just like C. In main function we may have functions like this, and inside these functions we may have like this, and inside of this one. So these are the some type of relations among the functions that are using in C existing languages, just like C. When we are increasing this the function sizes, and mean many functions maybe exist for a program to design a solution for a problem, it also might create a problem to the programmer or a user to particularly what type of function is sharing with the other data with the other functions, and what data is sharing among these functions. It is little bit typical for the process for the users or something like in this conventional programming. And here it is another problem there, global variables. So in generally in our programs we can declare the variables, local variables and global variables. When we are defining global variables, it may be a problem in conventional programming design, because these global variables can shared by several functions used in your program. And the concept is there any some errors there in existing particular accessing or this global data processing on that. In that case particularly we can get some problem to identify which function sharing this global variable and which function updating the values of these global variables to identifying is very typical in existing languages like C. And whereas coming to here, the sharing data by functions in non-object oriented programming languages, like there are some global variables are defined many for, and which function is accessing which type of global data, and this is creates some problem in conventional programming. These are the two main important disadvantages of conventional programming. So this is the two questions from unit 1, and next we move on to unit 2, the questions from 3 and 4. The first question 3 a bit, how the member functions can be defined in the inside class and outside of the class, explain. And the second question is, write a C++ program to define two overloaded functions to swap two integers and to swap two characters. The first one we see this one, member functions. Unit 2 is syllabus from classes and objects and constructor and destructor. So this question, third question A and B from classes and objects. So we'll see these two questions, how to answer these questions from unit 2. So here defining member functions inside and outside of a class, and here it is we have the possibility of defining member function inside and outside, in as usual we know that in class we have private section or public section, and you can define these member functions of a class inside and outside. And see here, When we are defining inside of the function, there is no need of taking care of any special syntax like that. But when we are defining outside of the member function, outside of the class, then we should follow one scope access operator or scope resolution operator to define that one. This is the syntax to define the function prototype inside the class and defining the function member function definition outside of the class. So here return type should be there, and class name followed by scope access operator followed by function name and parameter list. This prototype should be inside of the class, and the member function definition you are going to define outside of the class. This is mandatory condition. And we will see the example of defining member function inside of the class. So here in class I have a private section having some member variables like student data, name, roll number and branch. And inside public section I have a function called read function, and I'm reading these values for student. And I have another function called show, displaying the values of the student, whatever the details read by this read function, and the details are displaying on the output screen by this show function. So these two, read function and show function, these are the two member functions that are defined inside public section of the class only. Yes, it is. We need to define these member function. You may define private section under private section, or maybe public section of the class. So while calling these two functions using the object of the same class called s here, and it takes the values by using this function, it reads these values, and by this function it displays all the values on the output screen. So this is the way of defining member function inside the class. And quickly move on to this member function defining outside of the class. As I told you, when you are defining member function outside the class, the function member function prototype should be present in the inside of the class. So see here, take the same example. So here it is data members of the class student details, and this read function I defined this inside of the class, one member function. But I have another function called show, but this show function defined outside of the class, but this function prototype is defined inside class. This prototype declaration must and should be inside class. That here it is the void show. Void is a type of function, show is a function name. And outside this, as I told you, some syntax need to be followed here. See here, void is a return type of the function, student is a class name, and scope access operator, function name and parameter list. So this the syntax need to be followed when we are defining this member function outside, and the function body may contain under this scope of this function. So this is the way of defining function outside of the class. Okay, and we've seen this right now, how these member functions can be defined inside and outside of the class. Next question, third question B, write a C++ program to define two overloaded functions to swap two integers and to swap two characters. So see, let's see this program. So see here, functions, member functions we can define inside or outside, it's okay. But we have another feature called overloading in C++. We can overload the functions for any type of purposes. Let me explain the program. So see the example program of overloading functions in C++ class. So here I have a class sample here. I have four data member variables A, B, C, D. A, B are integer type, and T1 is a temporary variable, and character CD are the two character variables, and I have temporary variable C2 for swapping these two values. So in a given question, so we need to design one member function. Function name should be same, that is the overloading function concept call. The same function name can be used for multiple functions, and it works for the same operation. Here it is coming to here, this is the swap function for swapping integer values, and here it is the swap function for character values. So in this integer, the name of this function is swap. Here it is the function name is also swap. So this concept is called overloading functions, member functions inside the class. Here it is these two functions swapping integer variables and character variables respectively. And see here in this member function, swap member function, and I have swap using the swap concept between or for integer values. In this here, swap for character variables. Inside of main function, I have defined these data variables of integer type and character type, and I have created one sample object for this class called sample, and I called the swap of mn. Mn are the two integer variables, so this automatically gone for the integer swap member function. Specifically, the control and after compilation it automatically know about which swap function should be executed. This is the concept called of overloading function. So here another function z.swap. Again I'm passing two parameters to this function, and these two parameters are of type character, and automatically control calls the character member function that are defined inside the class with name swap, the function parameter list. Here it is these two member functions having same name swap, but the parameter list is types different. So this is concept called function overloading. Next one, from unit 2, we have another chapter called constructor and destructor. So fourth question, these two sub questions A and B from this constructor and destructor concept. See the first one, what is the use of constructor? Explain default parameterized and copy constructor with suitable example. So here, what is the use of this constructor? We know that constructor and destructors are the two special member functions of the class. Constructor is used for allocating memory for the object, and whereas destructor is the member function specially designed or defined inside the class for deallocating the memory for the classes objects. As we know that member functions can be defined inside and outside, same as constructor and destructor can define inside and outside of the class. Here it is, the main use of this constructor is that it one use it to allocate memory and allocating memory for the objects, and that are the objects held by the data variables of the class. Another usage is by using this constructor we can initialize the data members that are defined inside the class held by the object. And there are three types of constructor, as we know that constructor, default constructor, parameterized constructor, as well as copy constructor. And default constructor is nothing but as we know that the class when we are defining object for a particular class, there should be one default constructor should be present, and this constructor may be optional. It can user can create. If the user is not defined any default constructor for a class, the compiler automatically creates one default constructor at the time of compilation of the program. And whereas to coming to this parameterized constructor, in this parameterized constructor, the constructor can take, it is like a member function, it expects some parameters, and we can give some parameters to the constructor while it is calling for allocating memory or maybe initializing the variables for the object classes. So here that type of constructor we call that as a parameterized constructor. And especially this copy constructor is nothing but it is assigns nothing but an implicit assignment among the objects of the same classes that are values are copying from one class object to the another class object. So we will see this one in coming to the constructor types: default constructor, parameterized, and copy constructor. Here it is default constructor, nothing but inside class when we are defining a constructor with the same name of the class name like this one be considered as a default constructor. Here it is, we can use this default constructor for initializing also. So here it is one example of one default constructor. And by using when this constructor will call, when we are creating an object of this class, nothing but x is an object of data class, and when we are defining like this, so this constructor automatically implicitly executed by the compiler, it checks in the class definition, is there any default constructor defined inside the class or not. If it is not defined, the compiler automatically creates like this, or it may be user any defined constructor default like this constructor will call and execute and allocates for memory for this object called x. So this object contains the variable nothing but a and some initialization of this one. This task will be done by this default constructor or any constructor of defined in a class. And next one, parameterized constructor, nothing but we are passing arguments to the constructor when we are creating memory or initializing data variables of the class. So here when we are passing a parameter to a constructor, then it automatically call this type of constructors as a parameterized constructor. When we use this constructor for when creating objects for a class, so here it is data class, and now I am defining x is an object of this class, and I am passing one integer variable for this constructor and assigning this value to the something variable we are defining in the objects, like this value is defined and loaded into this one of the variable of the class. So this process of calling is like implicit calling, and we can call these constructors explicitly like this. And here the process of this parameterized constructor is when we are calling this constructor, we should need to pass a parameter to this constructor. And whereas another type of constructor, same parameterized constructor with default arguments, this is also one of the type of parameterized constructor. And when we call this creation of creating object by using this type of constructor, and these values are passed into this constructor, and if you are not passing any value to this constructor like this, here we are having two values defaultly defined for this parameterizer constructor, but I have given only one value, then only this value is loaded into this I, and this j automatically taken from default value. So this type of constructor also called as parameterized constructor. Coming to the copy constructor, in this copy constructor is nothing but we are passing object of the same class as a parameter to the constructor of the class. Just like here, this is copy constructor, and this is constructor with one argument, and this is default constructor. Like this is copy constructor. Here I am passing, here it is class num, constructor name is num, and I am passing one object, nothing but address of that object of the class of type class num, and I am assigning this value to particularly to variable n here in this class. So this is the copy constructor uses here, and we are assigning one object data value to the another object of the same class. So this is the use of copy constructor in the class. So we discussed about how use of these constructors and what are the types of constructors used in class programs. And coming to the another part, question B, how will you destroy the object initialized by the constructor in the program? Explain. Constructor is used to allocate the memory for the object, and whereas destructor can be used to deallocate the memory for the classes. And see the process, so how to it deallocates the memory for the object. Okay, here it is come to the example program, how this constructor can allocate memory, and this destructor how to deallocate the memory. So in this class A, I have a constructor like this, and it displaying constructor is calling, and this is the declaration of destructor in the class A, and it destroys the nothing but a memory allocated for the object. When we create an object of a particular class, nothing but object declaration, simply like this A space X, then when it is defined like this, automatically one constructor will call for allocating memory. Immediately after going out of the scope of this main function, automatically destructor will call for deallocating memory. So this is a simple process of how this destructor can be used to deallocate the memory, and it is a linked process with this constructor. The constructor is the process of defining ourselves to memory creating for the object, and destructor calling is automatically, if you are not defined this destructor, automatically one default destructor will automatically created by the compiler when the time of compiling the program. From this one, classes and objects and constructor and destructors. So this second unit is these two type of concepts are very important. And coming to unit 3, 5 and 6 questions. So fifth question and two parts. What is an operator overloading? And write rules to overload an operator. And what is the concept called this overloading is already we know with respect to the functions defined for the class or a program. And whereas it is allowed in C++ to overload the existing operators that are arithmetic operators like plus, minus, just like this different type. And what are the rules to overload these operators? That is the first question, important. And another important program is, as in C++ is a programming language. So as we know, this C++ program is a object-oriented programming language. So sometimes in our examination, program may be asked like this: write a C++ program to overload binary operator. Binary operator nothing but a plus. So binary operator is nothing but this operator is expecting two operands to perform this addition operator plus, and which will add two complex numbers of the form like a plus ib, and we are taking two complex numbers and adding these two complex numbers for the uh, addition of two complex numbers. So what is an operator overloading? So here see this one. For example, for operator plus and can be used to perform addition of two variables, but same is not applicable for the objects. So this is the concept where we got some problem with the programming, conventional programming. But whereas in C++, this feature is completely added. We can allow to overload the operators that are existing in our built-in, like plus, addition, subtraction, like that one. And the controller and nothing but a compiler know how to perform addition between the data types, primitive data types like integer and float, like that one. But the compiler doesn't know how to perform the addition among the objects of the same class. So in this situation, some of the times may want to perform addition among the two objects of data, nothing but data inside one object plus addition with the data in the other object of the same class. So this addition of this type of addition among the objects doesn't known by the compiler. So to achieve this one, we need to overload this existing addition operator without changing its natural property, and we can use this addition operator for performing the addition among the objects of the same class. So this is called operator overloading, and we will see what are the rules for this operator overloading. So coming to this rules of the operator overloading, so there are this just basically overloading operator cannot change the basic idea of an operator. That it means addition using that only use that addition for objects also. When operator is nothing but a keyword, operator in C++ is operator is a keyword that can be used to overload the operator that is existing. When we use this operator overloading, its properties like syntax, precedence, and associatively remain constant. When we are overloading any operator, that properties should be same as like the syntax given for the built-in existing operators in language. And this operator never change its natural meaning. That we are using addition operator overloading, that should be used for addition only, not for any other operation. Okay, so here that overloading can be the same. What I'm saying here, it is overloading operator plus can be used for subtraction of two objects. So but this type of code decrease the utility of program, so it is not used by any programmer or design of the programs working with this feature. And there are some type of features like this, some rules we need to be followed in. One, there is no higher limit to the number of overloading for any operator. You can overload many number of times of the same operator using in our language. And sir, there are many type of type here. Only existing operators can be overloaded. We cannot create any new operator by overloading. This is also one of the important. There are wide range of operators available in C++, but few operators cannot be overloaded to operate on the same manner like built-in operators. So some few operators are there, list of few operators that cannot be overloaded. See, let me show you. So see here, non-overloadable operators. So these are the set of operators that are non-overloadable operators. We cannot allow these to overload. Some friend function is one of the feature added in C++ compared with C, and non-overloadable operators with friend function. So this is also some list like this one. So see here, coming to the overloading operator, addition operator, binary operator plus. So here it is an example program, and in the exam we may ask write a C++ program to overload the binary operator plus, like that, between some complex numbers like. But I am explaining this normal integer variables like. So see here, in this class num, I have a two variables called x and y, and I have a default constructor and parameterized constructor for initializing these x and y variables with some values I and j, and I have an operator function. So this operator function specifically used to perform addition between the objects of the same class. See here, this statement is important here, and define a object with 2 3 values and another object of the same class with values 4 and 5. So I'm adding these two objects to form a new object C and loading into the values after addition of these A and B objects. So here this is object A data and this is object B data. I'm trying to perform addition among these two by using this operator function, operator overloading function. For this operator called plus, binary operator, nothing but plus operator, addition operator. After performing these addition among these two objects of the same class, the result of this object C, like that, as I shown this C equal to A plus B. So this is possible in C++ by overloading overloading function defined inside the class. We can define this operator overloading function like a member function inside of the class or maybe or outside of the class. So here the syntax for this defining operator overloading function, class name followed by operator keyword. This one is keyword operator and the symbol that representing what operator you are going to overload, and the parameter list nothing but the object of the same class. So here this C equal to A plus B, nothing but the B class object is, this operator function is called by this object A by passing B as a parameter. So this is syntax is very important, and here the same, here I am mentioning that this is equal to like this, C equal to A plus B or C equal to A dot operator plus B as a parameter. So here B object passing parameter to the operator function called by this A object. So this is the syntax, and here it is this addition operation performed among the two objects A and B and assigns to this temporary object T, and this T is returned and that whole by object C, and it displays the values like this. So this is nothing but overloading operator using operator overloading feature added to C++. Coming to the next one, next chapter from unit 3, that is inheritance. So here the two questions, sub questions given in 6th question A and B from inheritance concept. So the first question, explain the visibility of base class members for the access specifiers, private, public, protected, while creating the derived class, and also show the syntax for creating derived classes. And see this one, in inheritance we can allow to adopt the properties from one class to another class. What the properties we are inheriting from, that is nothing but a base class. What we are properties inheriting by the class, nothing but a derived class. And base class considered as a parent class and derived class considered as a child class. And accessing by this derived class from the base class, the data members defined inside the base class under the maybe private section, public and protected sections, and inheritance clearly mentioning that protected section is specially designed for inheritance, that protected section members of the base class can be allowed to access any derived class or any child class extended the properties of the parent class. So coming to here, for this I have a class A and I have members like this, and I have defined these members as private. First we will see access specifiers, how these members of the base class can be allowed to access for derived classes. And coming to class B, see here I have a class B followed by colon operator followed by public keyword followed by class name, that the properties we are going to extended by this class B. So here this class also having some members variables like this, but here this private data members cannot be accessible to the object of this base class or derived class B, even though it extended the properties of this one. This is a base class here and this is a derived class here, and the objects of this class, derived class, cannot allowed to access the private members of the base class. But whenever we have, just like here, just when the public section have this base class, this public section members can allowed to access by this objects of the derived class. So this is one of the important topic. Public member functions can allowed to access from outside of the class, that is already known. And in the inheritance concept, this the relation between this base and derived class, the public section base class members can be allowed to access by the derived class member functions through these objects. So coming to here, another member section of the class protected, and we know that right up to now, before this inheritance, default nothing but a private, and protected is work as same as the private section of the class. So here when the inheritance comes into the picture, this protected will come to change the process and behavior here. So see here the objects, when we have a protected members in the base class, and through these derived class objects we can allow to access the protected members of the base class. So these are the possibility of access the members of the base class from the derived class objects. And also here, how to the syntax for declaring or defining member derived class from the base class. As I told you that class A is a base class, that is some existing class like this, and consider this as a base class. I'm going to extending these properties to another class called derived class. So derived class, I'm creating class B. The syntax for this is followed by colon, followed by access specification. Either it may be a private or maybe a public or maybe a protected. Followed by the class name, the base class name, nothing but A in this case, base class name. So this is the syntax for deriving or defining derived class for the base classes. This is called inheritance concept here, and we can extend the same. For example, I have a class C followed by colon, public keyword access specification followed by A comma C. This is multiple inheritance. So this is the way of another syntax for defining derived class for the base classes. Another example like class, so here it is some members like this. Class D is extending properties publicly from B. See here, class A is a base class, class B is a derived class extending properties of A, and class D is also a derived class extending properties from the derived class. So this is multi-level inheritance. There are many type of inheritances are available features to extend the properties from one class to the another class. Coming to the second question from sixth question, second B question from sixth question. State any two forms of inheritance, give an example of each. So see here, there are many forms of inheritances. There are mainly type of differences. Let me explain. Okay, coming to the types of inheritance or forms of inheritance, there are many types of classifications here. The first one is single inheritance, multi-level, multiple, hierarchical, hybrid, and multi-path inheritance. See, let me show one by one. This is single inheritance, extending properties from one class to single base class, single derived class. And multi-level inheritance, multi-level extending one properties like x to y and y to z. This is multi-level inheritance. This is multiple inheritance. More than one parent, we are extending properties to one derived class. Hierarchical inheritance, see here, one class properties can be extended to multiple derived classes. Hybrid inheritance, combination of the previous inheritances, maybe single inheritance and multiple inheritance, just hybrid combination of the existing inheritances. Multipath inheritance, see here, one properties are extended from W to XY and XY properties are extending to properties to Z class. Next one, coming to unit 4. So in this unit 4 we have the two chapters called pointers, and second one is binding polymorphism and virtual function. Question 7, A and B. A, what is a pointer? So pointer is nothing but a referential to particular memory location. Pointer is also worked as a variable which holds the address of the another variable like that. And we learned these topics from C, but in C++ we have some more additional features added to this pointer concepts in C++ language. Then here it is, we can allow to declare this pointer to a class or an object. So how to declare this pointer to a class? How to declare this pointer to an object? And we will see this one clearly. Coming to question B, here write a C program to declare a pointer to derived class and access the member variables of base and derived class. And inheritance, we know that properties can be extended from base class to derived class by declaring a pointer to a derived class. Derived class pointer can allow to access base class members as well as derived class members, and we will see this program in clear. So here this program to declare a pointer to derived class and access the member variables of the base and derived class. So here in this class I have class A and public section one member variable and one member function displaying the value of this B. And I have another class called B extending properties of A with public point of view. And in this class B I have a public section and another variable D, and this display function displays the both B and D value. This is the properties behavior of these two classes using single inheritance, single class and single, one derived class and one base class. Coming to main function, here I can create a pointer to derived class and I'm trying to access the members of the base class as well as the derived class. So see here, I have defined one pointer to the object called B. B is nothing but, and class name class B is a derived class, and I defined one pointer here, and I have another object called B here for this class B, and I assigned the address of this to a pointer to this one. This is the process of creating a pointer to an object. So by creating this CP pointer to this current object of the derived class, I can allow to modify these values of the base class as well as the derived class. So B is a variable defined under base class and D is a variable defined in the derived class. I can access both these values to initialize and using this pointer object variable, that the pointer assigned to the object of the derived class, and it is allowed and displays these values like this. So this is one simple scenario to how to assign a pointer to an object and as well as how to assign this pointer to derived class to access the members of the base class as well as derived class. Okay, coming to another chapter from unit 4. See here virtual functions, nothing but binding in polymorphism. Here the first question, describe the mechanism of creating virtual functions in C++ with an example. And by using these virtual functions we can eliminate the process of working with the member functions as we getting some problem with overloading, and whereas here it is this virtual functions can create the runtime polymorphism in the C++ programs, and let me explain this one. And another question from here, it is B, what is polymorphism? And we know that polymorphism is nothing but a poly means many and morphism may be forms, and it can be used for one function may act as different functions like with the same name. And how these virtual functions can be used to implement runtime polymorphism. Runtime polymorphism can be achieved by using these virtual functions, and let me explain these two questions with the answer. Coming to the virtual functions, and we know that virtual functions of the base class should be redefined in the derived class. This can be used only using virtual keyword. Here the programmer can define a virtual function in the base class and can use the same function name in any derived class. So this is the feature, actually this will maybe name collision without using this virtual keyword, but by using this virtual keyword we can overcome this one. Even the number of time of arguments are matched. The matching function overrides the base class function of a similar name. Virtual functions can only be member functions. We can also declare the functions as given below. For example, consider this is a base class having some get function with integer parameter, and whereas in derived class the same function name with get with this parameter, and when they are not virtual So it might be a problem for that. Here it is coming to the base class version is available to derived class objects via scope override. If they are virtual, only the function associated with the actual type of object is available. With the virtual functions, we cannot alter just the function type. It illegal. Therefore, to reduce or redefine a virtual function, so it is very only in return type. So these are the some features available with this virtual keyword, and making this to overcome this the problem with the same name having the member function in derived class as well as the base class. So coming to the question B, polymorphism is a technique in which various forms of single function can be defined and shared by various objects to perform an operation. So here polymorphism is an operation can be achieved runtime or compile time. So late binding and early binding. So static binding is nothing but an early binding at compile time, late binding or a dynamic binding at runtime. And by using these virtual functions, this can be achieved late binding or at runtime binding, nothing but runtime polymorphism. And whereas at compile time, function overloading is comes under the static binding, nothing but a early binding or a static polymorphism. And operator overloading, this is also comes under the static overloading or static polymorphism. But using this virtual function concept, we can achieve this runtime or late binding at runtime polymorphism. So this is the possibility of implementing the polymorphism at runtime by using virtual keyword. Coming to unit 5, the two questions, the last two questions 9 and 10. So in unit 5 we have three chapters: generic programming, exception handling, and standard template library. And these two questions from these three chapters, the first one, generic programming, nothing but generic programming is the concept of defining the data variable types at runtime, not at compile time. And we can define template data types in our program as when we want to define without defining data type. And we can use these templates for functions as well as classes, and how these templates are useful to create design generic programming. And whereas coming to the exception handling, exception is nothing but a runtime error, and this runtime error can be should be handled, otherwise it can be terminate the program in abnormal condition. And we can use three types of keywords: try, catch, and throw. By using these three keywords, we can handle the exceptions generated at runtime. And coming to the another chapter from this unit 5 is standard template library. And these template libraries are very useful for creating generic programming in C++. And there are many template libraries defined, and these standard template libraries can be included into our programs for accessing those functions defined in the libraries. And see first one, the first question, ninth question, A, sub question A, what are class templates and how they are different from classes? Explain with suitable C++. And we know that the templates are two types: function template and class template. And the syntax for this class template is, so Angular brackets followed by class, and T is an optional name. Now the T considered as a template type, and you can use this capital T in your programs for any variable defining for your class. And at runtime, you can use some syntax like specifying that as an integer, then automatically this template compiler convert that runtime type to this template type for performing data operations in our programs. And coming to another one is a macro. And what are macros? Nothing but macro is like a type of function we can use in our programs, like pre-processor directives. And how this one is different from this templates. And this the two question, these two topics from this generic programming. I will let me explain the answer. Okay, coming to the class template. So the template declaration, and this is the syntax. Template is a keyword followed by angular braces, and between this angular brackets, and class is a keyword followed by type name, template type T. And you can use this T for defining your class members without defining the data type. And this is the syntax. And coming to this class type of function, function template, another function. See here. So this is function template example. So when we define any class template for this defining like this, when you use this statement before the declaration of any class in your program, so that class becomes a template class, and you can use this template type anywhere of your program for defining any variable or any parameter for constructor or maybe member functions like. And we can define this template type at runtime. So when we are defining this angular brace and type specifying, then controller automatically knows at runtime at the type of this character, this variable to this function is for this object is nothing but character type and integer type and maybe a float type. This is useful for this class template. Coming to the template function, see here the same similar type of syntax is for defining template function. So use this statement, template is a keyword, angular braces class keyword followed by something t. So t is not mandatory, you can use your name or any other alphabetical character for defining this template type. And the function declaration should be like this, and when we use this statement before any function declaration, then automatically this function converts that as a template function, and return type, function name and arguments and the body of the function like this. This is called function template, and we can use this template type for any type of variables working in this function. Like, coming to difference between template and macros. And macros are not type safe, that is, a macro defined for integers operations cannot accept float data. When we defined a macro for integer data operation, that is not support for float data, but whereas template can be used for both. When we defined a template data type, that can be used for processing the data of maybe type integer or maybe float. That is one of the advantage and difference. And coming to, they are expanded with no type checking, but in template it checks the type checking at runtime and it accepts the operations on data with mapping with this runtime data type. And it is difficult to find errors in macros, and when we define any type of logical errors exist me for processing on data, then it cannot be identified by using macros, but it is can easy, little bit easy to template uses. And coming to, in case of variable is post incremented, let me see one type of example like this. Post incremented or decremented, the operation is carried out twice when we use this macro. For example, for understanding this one, here I have defined one macro for finding maximum of a, and I am performing addition between operand a and incrementing pre-incrementing operator with this a, and I have defined this variable a, and here it is some macro uses for this program. Here it is, as I told you, this macro operation carried out twice. So this is the problem with macros, but this can be overcome by using simply a template in generic programming. Let's go for the same. So I have defined a one template type by finding the same max, but here I defined this k as a template type, and I have written the same incrementing operator, and I'm using the same code written in the previous macro style, but here it is, it executes only one time the increment, but in the previous one it executes two times and it getting some inconsistent values. Second chapter from the unit 5, exception handling. Nothing but exception is a runtime error. So I told you that exception can be handled in C++ by using three keywords: try, catch and throw. So here the question comes from this exception handling is, what should be placed inside try block for handling exception, and how this catch block can be organized to handle the exception thrown by this try block, and when to use this multiple catch handlers. So I will explain you the process of how this exception can be handled by using the three keywords. Let me explain. So see here, so this can be considered as a try block, and this can be considered as a catch block. Throw is a keyword. So by using these three keywords, we can handle the exception in the generated by in the program of C++. So try block is mainly contains the code that generates the errors, that generates the exceptions. So try block should be contain the code where this exceptions may be generated in our program. That code should be contained inside the try block. Whatever the exception generated inside this try block, that should be thrown. That should be thrown by this throw keyword, and the thrown exception should be catched by this catch block. Whatever the exception thrown by this try block, and throw using this throw keyword, we can throw this exception generated by throw try block, and the catch function nothing but a handler. Whatever the exception generated, that should be handled. As I told you, that should be handled, because whenever the exception is generated in our program execution at runtime, runtime exception is nothing but a runtime. Whenever this error is generated at runtime, it should be handled. Otherwise, our program should be terminated, maybe terminated in abnormal condition. Then due to that abnormal conditions or termination, the data inconsistencies may be occurred. So that's why we need to handle these exceptions at runtime. So for handling these exceptions at runtime, this catch block can be used. This catch block automatically handles, and this part of code, this body of this catch block should give the routine to handle these exceptions generated by try block. So this is the scenario of using these three keywords for handling the exception generated in the programs. But whereas coming to the multiple catch statements, sometimes maybe you can use catch 1, catch 2, some type this another catch function or catch block, another catch block 3, just like this. So whenever this exception is generated by this try block, and this exception maybe belongs to catch 1, or maybe belongs to catch 2, or maybe belongs to catch 3, and the accessing of this exception order, like first this generated exception checks for the catch block of first defined in your program, and it verifies if this syntax is matched with this exception handling or not. When it is matched this definition, this exception can be handled by this catch block. Otherwise, automatically control goes and check the remaining catch blocks defined in our program and checks with the second one. If it is matched with this catch block, then this exception can handled by this catch block. This type of scenario is adopted to handle the exception with multiple catch statements. So see this one. So how should we plug this inside a try block, catch block, and when to use this multiple catch handlers? Catch handlers are very important, need to be take care when we defining to handle the exception generated by the try block and throw by the throw keyword. Next, coming to the B question in the 10th question. So here, explain briefly the three functional items of the standard template library. As there are three important items for the standard template library, and let me explain one by one. Okay, coming to the three important parts of the standard template library, this STL is divided into three parts, namely containers, algorithms, and iterators. So let me coming to the containers point of view. So this containers consists of two types: associative containers, sequence containers. In these associative containers, these are the things need to be take care for these containers. Why? Because these containers allow sequential and random access to the members, and this associative container allows access to their element through key. And this sequence containers also the type of container. This it is very important part in defining a standard template library. And second one, going to algorithms. So an algorithm is a technique that is useful to handle the data stored in containers. Whatever the data we stored in the first part of the STL is containers, and this STL comprises of approximately 60 standard algorithms that are already defined to support to perform frequent and primary operations such as copying, finding, sorting, merging, and initializing. And many more algorithms are already predefined in the algorithms of the standard template library. And these standard algorithms are defined in header file called this one algorithm. We can include this algorithm template library into our programs, and we can use these 60 standard algorithms. And coming to the next one, iterators. So here iterator is an object, exactly behaves like a pointers, and we know the pointer is the referential to a particular memory location, or it can be access of data from the memory or like that. So it indicates pointer to data elements in container, and we know that container contains the data elements, and algorithms are used to perform operations on the data stored in the container, and these pointers also locating this indicating the pointer to data element, and it is utilized to move between the data items of the container. Sometimes the data movement may be possible among the containers of the standard template library. So iterators can be incremented or decremented like pointers. As we know that pointer can be incremented or decremented. The same way iterators can be used to increment or decrement. Iterators link algorithms with containers because containers contains the data and algorithms are the nothing but operations on these data. And these iterators link these two for uh, performing some operations in our programs. And coming to say type of containers, we know that this sequence containers, associative containers, sometimes we call the derived containers. And we know that sequence containers contains the data like vector, DQ, list, and associative containers set, multiset, map, multimap, and the derived containers stack queue, priority queue, and we know all these are some data structures, element processing, and storing the data, how these data can be accessed in our program for processing. Now, coming to algorithms, there are different types of algorithms are already predefined that are can be loaded into your programs by using the standard template libraries. And these are also some more examples, and I know that I told you that 60 standard algorithms are already defined in STL of C++. And coming to the iterators, and these are the different operations that are possible to perform on the container classes, and these iterators are mainly used in our data for processing, moving forward, bidirectional, random, and input and output, giving some data to the data structures like vector and the sets like that, you can know that. And iterator status, knowing by these three types of statuses for iterator. And these are the three main parts for standard template library. As I told you that containers is the first one, and algorithms is the second one, and iterators is the third one. Thank you.